There is an island at the bottom of the world. It sits below the Australian mainland, separated from it by a stretch of wild, cold water called the Bass Strait. The winds that cross that strait come from the Southern Ocean, and the Southern Ocean comes from nowhere. There is no landmass between Tasmania and Antarctica, just open water, and below that, ice. Most people who have not been to Tasmania picture it as a smaller, quieter version of the mainland. Green hills, some wildlife. A place you might visit if you wanted fresh air and good cheese and a slower pace of life. And that is true. Tasmania is all of those things. But there is another Tasmania, one that most people never encounter. One that exists beneath the island's visible surface, behind its sealed cave walls, underneath its ancient peat bogs, inside its drowned river valleys, and its unmapped karst chambers. One that does not appear in the tourist brochures. That Tasmania is older than you can comfortably hold in your mind. Stonehenge was built approximately 5,000 years ago. The Great Pyramid of Giza is roughly 4,500 years old. The oldest known written language appeared about 5,000 years ago in Mesopotamia. Every major monument that we tend to think of when we imagine human antiquity, every structure that makes us feel the weight of deep time, dates to within the last 5,000 or 6,000 years. The things sealed beneath Tasmania are older than all of that, not by a little, not by a few centuries, by tens of thousands of years. Some of what lies beneath that island, sealed under sediment and limestone and peat and water, is 60,000 years old. Some of it is older than that. There are cave systems in the southwest of Tasmania that have not been fully explored. There are karst chambers whose sealed sections have never been opened. There are peat bogs that contain a continuous record of climate, vegetation, and human activity going back 10,000 years without a single gap. There are valleys in the southwest wilderness that no human being alive has walked through. This is not mythology. This is geology, this is archaeology, this is paleoclimatology and paleontology, and a very long list of scientific disciplines that have been quietly working in that corner of the world for decades, pulling up things that should not exist and publishing papers that most of the world never reads. Tonight, we are going to slow down. We are going to move through this material carefully, the way you would move through a very dark, very old place, one step at a time with a small light. The story of what is sealed beneath Tasmania is not a dramatic one in the Hollywood sense. There are no monsters, there are no conspiracies. What it is, instead, is something quieter and in some ways more unsettling. It is the story of a place that has been left alone long enough that time itself has become a physical substance you can hold in your hands. Get comfortable, let your breathing slow. We are going to start at the beginning, and the beginning in Tasmania is a very long time ago. Number 1, the island that was cut off from the world. To understand what is sealed beneath Tasmania, you first need to understand why Tasmania is isolated in the way that it is. Because the isolation is not just geographical, it is temporal, and the timeline of that isolation is one of the most important facts in this entire story. Approximately 42,000 years ago, human beings first arrived in what is now Tasmania. We know this because archaeologists have found their tools, their fireplaces, their food remains inside caves in the southwest of the island. At the time of that first arrival, Tasmania was not an island. It was the southern tip of a much larger landmass. The Bass Strait did not exist. Where that cold stretch of water now sits, there was dry land, and across that dry land, human beings walked south. They walked south because the climate was driving them. This was during the last glacial maximum, the period when global temperatures were at their lowest and ice sheets covered enormous portions of the Earth's surface. In Australia, that meant the interior of the continent was drier, colder, and less hospitable than it is today. The coastal fringe in the south was still livable, and so people moved toward the places where they could survive. The people who walked into what is now Tasmania 42,000 years ago were entering a landscape that no human had ever seen before. They were the first people to stand on those hills, to look out at those valleys, to sit beside those rivers. They were the first to learn which plants were edible and which were not, which caves were dry and which flooded in winter, which coastal routes gave shelter from the wind and which did not. They were the first to develop the knowledge needed to survive in one of the most challenging environments on the planet. And then, approximately 10,000 years ago, the climate changed. The last glacial period ended. Global temperatures rose. The ice sheets melted, sea levels climbed, and the land bridge connecting what is now Tasmania to the Australian mainland slowly, over centuries, disappeared beneath the rising Bass Strait. 10,000 years ago, the people in Tasmania became islanders. They did not choose this. There was no moment of decision, no awareness of what was happening. The sea rose slowly enough that no single generation would have noticed the change, but the cumulative effect was absolute. By the time the Bass Strait had finished forming, Tasmania was an island, separated from the mainland by 140 kilometers of open water, and the people who lived there had no boats capable of crossing it. What followed is one of the most remarkable stories in human prehistory, For the next 10,000 years, the Aboriginal people of Tasmania lived in complete isolation from every other human population on Earth. Not relative isolation, not the kind of isolation where contact was rare. Complete isolation. There was no exchange of people, no exchange of tools, no exchange of ideas, no exchange of disease, no exchange of anything for 10,000 years. That is 5 times longer than the entire span of recorded Western history. 5 times longer than the gap between us and the construction of Stonehenge. The implications of this are profound, and we will return to them. But for now, hold on to this single fact. When the Bass Strait closed 10,000 years ago, it did not just separate Tasmania from the mainland. It sealed something inside the island. It sealed a way of life, a body of knowledge, a set of tools, a relationship with a landscape that had been developing for 42,000 years. And much of what was sealed inside that island is still there, waiting beneath its surface. That is where this story begins. Number 2, the oldest continuous human culture on the planet Earth. Before we go any further into what lies beneath the ground, we need to spend some time with the people who lived above it, because the human story of Tasmania is inseparable from the geological one, and the human story is, in many ways, the more astonishing of the two. The Aboriginal Tasmanians are, by most archaeological and anthropological assessment, the most isolated human population that has ever existed. 10,000 years of complete separation from all other human contact. Let that settle for a moment. To put it in a different frame, when the Bass Strait closed and the Tasmanians became islanders, farming had not yet been invented anywhere on Earth. The wheel did not exist, writing did not exist, no city had ever been built. Every human being alive at that moment was a hunter-gatherer, living in small mobile groups, following game and seasonal food sources across landscapes that most of them knew intimately. Agriculture was still several thousand years away. Civilization, in the sense that most people use the word, was still a very long time in the future. The Aboriginal Tasmanians remained living in that hunter-gatherer world for the entire duration of the period during which everyone else on Earth invented farming, built cities, developed writing, constructed Stonehenge and the pyramids and the great temples of Mesopotamia and the palaces of the Minoans and the roads of Rome and the cathedrals of medieval Europe. While all of that was happening, on an island at the bottom of the world, a group of people were living exactly as their ancestors had lived, inside the same landscape, hunting the same animals, gathering the same plants, sheltering in the same caves. And here is what that means for the ground beneath their feet. Every place they used leaves a trace. Every fire they lit leaves charcoal. Every bone they cracked for marrow leaves a fragment. Every stone tool they napped and discarded leaves a flake. And in Tasmania, these traces accumulated for 42,000 years without interruption. In a limestone cave in the southwest of the island, you can find layer after layer after layer of these traces, one on top of the other, each layer representing a period of human occupation going back further than you would expect human beings to have been in that part of the world at all. The cave sites in southwestern Tasmania are not just old, they are continuously occupied old sites. There is a difference. A single tool found in a cave might tell you that one person was there once. A continuous stratigraphy of charcoal, bone, stone tools, and hearths tells you that people came back to that cave, generation after generation, for tens of thousands of years. They knew that cave. They had a relationship with it. It was part of their world in a way that goes beyond anything we can describe using the language of tourism or archaeology. The sealed layers in those cave floors are, in a very real sense, a library written not in text, but in the physical residue of human lives. And most of that library has not yet been read. The excavations that have been conducted in Tasmanian cave sites have sampled only a small fraction of the available stratigraphy. There are sealed chambers that have never been opened. There are cave floors that have never been touched by a trowel. Whatever is inside them is still there, sealed under the sediment, waiting. Number 3, the Huon pine and the memory of living things. There is a tree growing in Tasmania that was already old when Julius Caesar was alive. When the Roman Empire was at the height of its power, this tree was already 2,000 years into its life. When the first European settlement in Australia was established in 1788, this tree was already older than any nation that had ever been founded on the continent. The Huon pine, Lagerostrobos franklini, is one of the slowest growing and longest living trees on Earth. Individual specimens have been confirmed at ages exceeding 2,500 years. Clonal stands, where a single root system has been generating new trunks over millennia, have been dated to more than 10,000 years old. There is a Huon pine stand in western Tasmania that began growing before the Bass Strait finished forming. That is not a metaphor, that is a biological fact. The tree was already alive when the last land bridge between Tasmania and the mainland disappeared beneath the rising sea. It was there when the island became an island. It has been there ever since. But the Huon pine is not merely a curiosity of longevity, it is also a record. The rings inside a Huon pine trunk represent an unbroken chronicle of climate going back thousands of years. Each ring corresponds to a year of growth, and the width and density of that ring encodes information about the temperature and rainfall and growing conditions of that specific year. A trunk that is 2,500 years old contains 2,500 data points about the Tasmanian climate, each one precisely dated. When dendrochronologists, the scientists who read tree rings, cross-reference the records from multiple Huon pine specimens, they can construct a climate chronology that goes back further than any other tree ring record in the southern hemisphere. The current Huon pine chronology extends back approximately 3,800 years. Ongoing work is pushing it further, but beyond the living trees, there is something even more remarkable. Dead Huon pines do not rot. The wood contains a high concentration of natural preservatives, oils, and resins that protect it from decay for extraordinary periods. Dead Huon pine trunks, lying in the cold, waterlogged sediment of Tasmanian rivers and lake beds, have been preserved in a state that allows them to be dated and their rings to be read. Subfossil Huon pine from these sediment deposits has been found and dated at ages exceeding 50,000 years. The trees that produced this wood were growing and dying in Tasmania before modern human beings had arrived on the island, before the last glacial maximum, before any of the events we have discussed so far. Their rings record climate data from a period that predates every archaeological site we have found in the southwest. This is wood you could touch with your hand that grew in a Tasmania that no human being has ever seen. The lakes in western Tasmania are full of it. Lake Johnston, Lake Vera, the Denison River catchment, the lake beds hold these ancient trunks in cold, oxygen-poor sediment that preserves them across timescales that make conventional archaeology look like a footnote. They are sealed beneath the water and the sediment, and they are still there, and they are still legible, and scientists are still reading them. Number 4. Kutikina Cave and the world that was sealed inside it. In 1981, a party of wilderness canoeists paddled down the Franklin River in southwestern Tasmania. The Franklin was, at that time, at the centre of one of the most significant environmental campaigns in Australian history. The Tasmanian government had plans to dam the river, flooding the valley, and destroying whatever lay inside it. The conservation movement was fighting to stop them. The canoeists who paddled the Franklin in 1981 were not archaeologists. They were activists and adventurers, people who wanted to see the river before it potentially disappeared beneath a reservoir. But on the limestone bluffs above the river, they found something that changed the nature of the entire debate. They found a cave. Inside the cave, just below the surface of the floor sediment, they found the remains of a fireplace. Charcoal, ash, burned bone, the unmistakable signature of human habitation. They photographed it, recorded the location, and got word to the archaeologists. Within months, a team was in the cave with trowels and brushes, carefully removing the sediment layer by layer. What they found beneath the surface remains one of the most significant archaeological discoveries in Australian history. The cave, which came to be known as Kutikina, contained a stratigraphic sequence of human occupation dating back more than 19,000 years. 19,000 years. The lowest levels of the cave floor, the layers that had been sealed beneath the accumulated sediment of all the years since, contained the remains of fireplaces and the bones of animals and the flaked stone of tools from a period when the last glacial maximum was at its most intense, when the world outside the cave was colder and more hostile than anything alive today has ever experienced. The people who lit those fires at the bottom of Kutikina Cave were living at the edge of survival. The temperature outside would have been 8 to 10 degrees Celsius colder than it is today. The wind that came off the ice sheets to the south would have been brutal. The landscape around the cave would have been largely treeless. A tundra-like environment of grasses and low scrub, swept by cold winds off an ice sheet that covered the mountains to the west, and yet there they were. People. Families presumably, children and old people as well as hunters, sitting around a fire inside a limestone cave, cracking wallaby bones to get at the marrow, napping stone tools by firelight, talking to each other in a language that no living person has ever heard. 19,000 years ago. The discovery of Kutikina was important for the Franklin Dam debate because it proved that the valley contained irreplaceable archaeological heritage. It helped turn the political tide. The dam was never built. The Franklin River still flows. But here's the thing about Kutikina that does not get discussed enough. The cave was sampled, not fully excavated. The archaeologists who worked there in the early 1980s, in difficult conditions, with limited time and resources, took samples from various parts of the floor and documented the stratigraphy. They did not remove the contents of the cave. Most of what is inside Kutikina is still inside it. The sealed layers below the excavation trenches are still sealed. The walls of the cave still hold whatever pressed against them all those thousands of years ago. And Kutikina is not alone. The Franklin River system has multiple cave sites. Dean Arena, downstream from Kutikina, also returned dates over 15,000 years. The entire karst system of the southwest has never been fully surveyed. In a landscape that is still, in large areas, genuinely unexplored, there are almost certainly other caves, other sealed floors, other fireplaces that have been cold for tens of thousands of years. They are still there, the river still runs past them, and the sediment still holds whatever it held when it first formed. Number 5, the Florentine Valley and the forest that drowned. There are places in Tasmania where, if you drain a lake or look down into the bed of a slow-moving river, you will see something that stops you where you stand. Trees, not the remains of trees, not the suggestion of trees, trees. Standing upright, in the positions they occupied when they died, their trunks still intact, their root systems still gripping the sediment beneath them. Dead, yes, and dead for a very long time, but structurally present in a way that feels less like archaeology and more like something paused. These are the drowned forests of Tasmania, and they exist because of a specific convergence of the island's geology and hydrology. When water levels rise in the low-lying valleys of western and central Tasmania, either through natural processes or, more recently, through the construction of hydroelectric dams, they inundate forests that have been growing for thousands of years. The trees die, but they do not fall. The cold, often acidic low-oxygen water preserves their structure. And when the water level drops, or when survey divers go down to look, there they are. Forests that were alive centuries or millennia ago, still standing in the positions they occupied when the water found them. In Lake Pedder, before it was dramatically enlarged by the hydroelectric scheme in 1972, there was an original lake floor that had accumulated organic sediment for thousands of years. When the new dam raised the water level, that floor was submerged under additional meters of water. Beneath that water is a sealed organic record of the original lake's history, layer upon layer of pollen, charcoal, plant material, and aquatic sediment going back to the end of the last glacial period. That record is still down there, sealed under cold, dark water and decades of additional sediment. Pristine because nothing can reach it, and nothing has disturbed it since the flooding. Scientists have extracted sediment cores from the enlarged lake, and even through the layer of post-dam sediment, they can read the record of the original lake below. The pollen in those cores represents every plant that flowered within a certain radius of that lake, going back 10,000 years. It is a map of a vanished landscape preserved in microscopic grains of ancient plant material, sealed beneath meters of water. The Florentine Valley to the north has its own drowned story. The forests of the Florentine have been logged, debated, contested, and partially cleared. But in the waterlogged ground of the valley floor, in the anaerobic sediment beneath the standing trees, there are the remains of earlier forests, logs and stumps dating back thousands of years, preserved in the wet, acidic soil because oxygen cannot reach them. A stratigraphy of forest history that begins before any European set foot in Tasmania and extends back toward the end of the last ice age. In some sections of the Florentine Valley floor, you can push a probe into the sediment and encounter wood at depths that correspond to ages of 4, 5, 6,000 years. The tree that produced that wood was alive and growing in the Florentine Valley when the Egyptian Old Kingdom was building pyramids. When it died, it fell, and the wet soil swallowed it, and the sediment sealed it, and there it has been ever since, completely unaware that the world above it changed beyond recognition. Number 6. The karst caves nobody has finished exploring. Tasmania sits on some of the most extensively karstified limestone in the southern hemisphere. Karst is the term geologists use for landscapes formed when slightly acidic groundwater slowly dissolves the rock beneath the surface, carving out passages and chambers over millions of years. The result is a landscape of caves, sinkholes, underground rivers, and hidden chambers that can extend for kilometers beneath the visible surface. The karst systems of Tasmania are old. Some of the cave passages began forming tens of millions of years ago, long before any human being existed anywhere on Earth. They have been dissolving and enlarging and collapsing and reforming across timescales that dwarf human prehistory. And within those ancient passages, in the sediment that has washed in from the surface and settled onto cave floors over thousands of years, the record of everything that has happened on the surface above is encoded. Mole Creek in northern Tasmania is the most extensively explored karst area in the state. The cave systems there, including Maricopa Cave and King Solomon's Cave, are well documented and partially open to visitors. But even in this relatively well explored area, there are sealed passages that have never been entered. Passages that are too narrow for a human body, or that require diving equipment to access because they are submerged, or that are simply not yet connected to any known passage and whose existence is only inferred from the pattern of surface sinkholes and the behavior of underground water. In the southwest, the karst is far less explored. The combination of extreme remoteness, difficult terrain, and wet, cold weather has meant that systematic speleological survey of the region has been patchy at best. There are caves in the Southwest National Park that were first entered within the last few decades. There are entrances that have been noted but not fully explored. There are surface depressions that suggest cave systems beneath but have not been excavated to find an entrance. What is inside the sealed passages of the Tasmanian karst? At minimum, sediment records. Cave sediments, protected from the weathering that destroys surface deposits, can preserve pollen, charcoal, bone, and other organic material for extraordinary lengths of time. In caves that were used as den sites by Tasmanian devils or as nesting sites by birds, these sediments can contain the bones of animals going back tens of thousands of years. offering a window into Tasmania's prehistoric fauna that surface sites simply cannot provide. In caves that were used by people, the sediments contain the record of those visits, layer upon layer of occupation evidence going back to the earliest human presence on the island. And in the sealed chambers, the chambers that are separated from the explored passages by a constriction too tight for a human to pass, or by a sump of cold underground water that has never been dived, there may be things that no human eyes have seen since the people who left them there 40 or 50,000 years ago. That is not a romantic fantasy. That is the realistic assessment of professional cave explorers who know this landscape. The sealed passages of the Tasmanian karst are, by any reasonable calculation, among the most archaeologically significant unmapped spaces in Australia. Number 7. The rock art that does not belong to the period we expected. Tasmania has rock art. This should not come as a surprise. Aboriginal Australians have been making images on rock surfaces for tens of thousands of years across the continent, and there is no reason why the people of Tasmania would have been different. But the rock art of Tasmania is, in certain respects, different from what archaeologists expected to find. The art known to exist in Tasmania is largely geometric: lines, circles, arcs, grids, and abstract patterns engraved into rock surfaces, or, in some cases, painted on cave walls using ochre. This stands in contrast to the more figurative rock art found in other parts of Australia, where animals, human figures, and scenes from daily life are commonly depicted. For a long time, the prevailing interpretation was that the Tasmanian people, in their isolation, had simply developed a different artistic tradition, a more abstract one. The absence of figurative images was explained as a cultural choice, a stylistic preference particular to Tasmanian Aboriginal society. But more recent work has complicated this picture. In a small number of protected cave and rock shelter sites in the southwest, faint traces of what may be very early figurative images have been identified. Images that are overlain by the geometric art buried beneath later ochre deposits, visible only under specific lighting conditions or with multispectral imaging technology. The interpretation of these images is contested and the subject of ongoing research. Some researchers believe they represent an earlier artistic tradition that was superseded by the geometric forms. Others are more cautious. What is not contested is the age of some of the art. Dates obtained from ochre samples associated with the art and from sediment layers that seal the base of painted panels have returned results in the range of 15 to 20,000 years for some southwestern sites. 20,000 years? Art made by human hands 20,000 years ago, still visible on cave walls in the Tasmanian wilderness. But here is the question that troubles the researchers who work on this material. If the accessible known sites return dates of 20,000 years, what might be inside the sealed caves? The ones that no one has entered yet? The ones whose floors are intact? In the accessible sites, the art has been exposed to millennia of moisture fluctuation, animal activity, and whatever physical processes occur inside a cave over very long periods. In the sealed chambers, the art would have been protected. If there are painted caves in the sealed karst of southwestern Tasmania, and the probability that there are is not small, the condition of whatever was painted on those walls might be extraordinary. We simply do not know, because we have not found them yet. Number 8. The Bass Strait Shelf and the Drowned World Beneath the Water. When the Bass Strait closed 10,000 years ago, it did not simply create an ocean, it drowned a landscape. Before the sea rose to its current level, the Bass Strait was a low-lying plain crossed by rivers. Those rivers connected the Tasmanian highlands to the southeastern corner of the Australian mainland. People walked along them. Animals sheltered in their valleys. Vegetation grew along their banks. There were hills and waterholes and camping places, and all the features that a human population needs to navigate and survive in a landscape. All of it went under the water. The Bass Strait sits at an average depth of approximately 60 to 70 meters. The continental shelf below the strait is relatively shallow, which means that during the glacial maximum, when sea levels were lower by as much as 120 meters globally, a significant portion of what is now the seafloor was dry land. That land connected Tasmania to the mainland for potentially 30,000 years before the sea finally covered it. 30,000 years of human habitation. 30,000 years of campsites and fireplaces and tool-making locations and hunting grounds and sacred sites, and all the accumulated evidence of human life in a landscape. And then the sea rose and it all went under, and it has been sitting on the floor of the Bass Strait ever since. Marine archaeologists have a technical term for these submerged landscapes: drowned landscapes or submerged cultural heritage sites. They are found all over the world, wherever the continental shelf is shallow enough that it was once above sea level. The Gulf of Carpentaria in northern Australia, the North Sea shelf between Britain and mainland Europe, the Persian Gulf, coastal areas of Southeast Asia, where the Sunda Shelf once supported enormous populations, The Bass Strait Shelf is among the least surveyed of these areas anywhere in the world. The combination of remote location, extremely rough conditions, and the sheer expense of marine archaeological survey has meant that almost nothing systematic has been done to document what lies on the strait's floor. There have been accidental discoveries, fishing trawlers bringing up bones and worked stone, reports from divers of anomalous features on the seafloor, but no comprehensive program of investigation. What is down there? The sediment on the Bass Strait floor has been accumulating since the sea covered the land 10,000 years ago. In that 10,000 years, the original surface has been buried under layers of marine sediment. In places, the burial is deep enough that the old land surface is well below the current seafloor. In other places, current patterns and submarine topography mean that the original surface is closer to the current floor level. The bones of the megafauna that roamed the plain before its submersion would be down there. The sites where people camped beside the rivers, the hearths, the stone tools, the organic material preserved by the cold, low oxygen conditions of the seafloor sediment. The drowned rivers themselves, channels cut into the seafloor that are clearly visible in bathymetric surveys, navigable by the people who followed their banks 10,000 years ago. It is a drowned world, and it is sealed under 40 to 60 meters of cold salt water and a layer of marine sediment. And almost none of it has been looked at. Number 9. The peat bogs and what they remember. Southwest Tasmania has the largest area of blanket bog outside of northern Europe and Patagonia. These are not swamps in the popular sense. They are thick, deep, ancient accumulations of partially decomposed plant material, built up over thousands of years in conditions where the rate of plant growth exceeds the rate of decomposition. The water that saturates them is cold, acidic, and low in oxygen, and those conditions are what make them extraordinary. In the right conditions, peat preserves almost everything: pollen, spores, seeds, the chitinous exoskeletons of insects. The shells of tiny aquatic organisms, fragments of charcoal from fires lit nearby, human hair, textiles, the occasional human body preserved so completely that the last meal the person ate can be identified. The peat bogs of northern Europe have yielded the famous bog bodies, human remains from the Iron Age, and earlier preserved so remarkably that researchers can reconstruct not just their physical appearance, but the circumstances of their death. Tollund man in Denmark, Lindo man in Britain, the dozens of others that have been found in the peat of northern latitudes. The same preservation chemistry applies everywhere that similar bogs exist. In Tasmania, the blanket bogs of the southwest cover tens of thousands of hectares. They have been accumulating since the climate warmed at the end of the last glacial period. In some locations, the peat is several meters deep, and the deepest layers represent the earliest post-glacial period, somewhere between 10 and 12,000 years ago. Sediment cores taken from Tasmanian peatlands have returned unbroken pollen sequences going back 10,000 years. Unbroken, not sampled at intervals, continuous records of vegetation change, climate fluctuation, fire frequency, and human activity captured in the pollen and charcoal that settled into the bog surface year after year, decade after decade, millennium after millennium. These records show things that written history cannot. They show the arrival of the first people in the region, visible as a sudden increase in fire frequency, and a corresponding shift in vegetation. They show drought periods and wet periods, cold spells and warm phases. They show the slow changes in forest composition as species track the shifting climate over millennia. They show things that no human being was alive to write down, because the writing of these things was done by the bog itself, in the language of microscopic particles settling slowly through cold, dark water. In areas of the southwest that have never had a core taken, the records are still there, still intact, still accumulating. Every year that passes without a disturbance adds another layer to the archive. The peat bogs of southwestern Tasmania are, in the most literal sense possible, a library that is still being written, and most of it has never been read. The number of sediment cores that have been extracted from Tasmanian peatlands, relative to the total area of peat available, is vanishingly small. The funding, the logistics, the sheer difficulty of working in that remote, wet, cold terrain limits what can be done. The southwest wilderness is not easily accessible. There are no roads through most of it. Many of the peatland areas can only be reached on foot, after days of walking through country that routinely receives over 3 meters of rain a year. But the records are there, sealed in the cold acidic darkness beneath the bog surface, patient in the way that geological things are patient, waiting for the people who have the tools to read them. Number 10. The thylacine and the evidence that has not been found yet. The thylacine, Thylacinus cynocephalus, the Tasmanian tiger, is the most famous extinct animal in Australian history. It was the largest carnivorous marsupial to survive into the modern era. It was hunted to extinction by European settlers in the 20th century. The last known individual died in the Hobart Zoo in September 1936. Most people know this much. What fewer people know is that the story of the thylacine is encoded in the ground beneath Tasmania, in a record that extends far beyond the historical period and that tells a more complicated story than the simple narrative of European-caused extinction. The thylacine was not always confined to Tasmania. For most of the period of human presence in Australia, it lived across the entire continent. It was present in mainland Australia for tens of thousands of years, and its bones have been found in archaeological and paleontological sites from one end of the continent to the other. Rock art depicting the thylacine has been found in the Pilbara region of Western Australia, dated to several thousand years ago, at a time when the animal was still present in those areas. Then it disappeared from the mainland. The timing of that disappearance has been the subject of considerable debate among researchers, but most current assessments place it at approximately 2,000 to 3,000 years ago, and in Tasmania it survived. The thylacine persisted on the island for thousands of years after its mainland extinction, right up until Europeans arrived and systematically killed it. The question of why the thylacine survived in Tasmania while disappearing from the mainland is partly answered by the island's isolation. Whatever pressures caused the mainland extinction, whether changing climate, increased human hunting pressure, or competition with the dingo, which was introduced to Australia several thousand years ago, none of these reached Tasmania. The dingo never crossed the Bass Strait. The specific conditions that drove the mainland extinction did not apply to the island, but the bones of the thylacine in Tasmanian cave sediments are not just a record of its extinction. They are a record of its population dynamics across thousands of years. In the sealed layers of Tasmanian caves, in the sediment that has been accumulating since the end of the last glacial period, there are thylacine bones from every period of the island's post-glacial history. In the deepest layers, alongside the oldest human occupation evidence, and in the shallower layers, closer to the European period, and in many layers in between. These bones can tell researchers about the animal's diet, its health, its genetic history, its population density, and its relationship with the human population that shared the island with it. Ancient DNA extracted from cave-sealed thylacine bones can be compared with DNA from museum specimens of the historical population to track genetic changes across thousands of years. But the sealed sediment also holds the bones of many other animals: the Tasmanian devil, currently endangered on the mainland, and declining in Tasmania due to a transmissible cancer; the eastern quoll, extinct on the mainland; the spotted-tail quoll; many other species whose populations have contracted or whose mainland relatives are gone. The cave sediments of Tasmania hold a biological record of these species going back further than any other available source. In the sealed layers of unexplored Tasmanian caves, there are almost certainly the bones of animals we did not know lived in Tasmania, or that we did not know survived there as late as they did, or that we did not know were present in the numbers that the bone density suggests. The faunal record preserved in the Tasmanian karst is, in all probability, substantially richer than what we currently know. We do not know what is down there. That is the honest assessment. We have sampled enough to know the record is rich. We have not sampled enough to know its limits. Number 11. The Tarkine and the rainforest that survived everything. In the northwest of Tasmania, there is a rainforest that is unlike any other place on Earth. The Tarkine is approximately 470,000 hectares of temperate rainforest, moorland, and wild coast. It is the largest area of ancient Gondwanan rainforest in Australia, and one of the largest in the world. When scientists describe it as Gondwanan, they mean something specific and significant. They mean that the species composition of this forest, the mix of trees and mosses and ferns that make up its understory, traces its origins to the supercontinent Gondwana, which began to break apart approximately 180 million years ago. The trees in the Tarkine are old, but the lineages are almost incomprehensibly old. The myrtle beech, Nothofagus cunninghami, the dominant tree of the Tarkine, belongs to a genus that was present on Gondwana before the separation of Australia and Antarctica, before the opening of the Southern Ocean, before the Australian continent began its long drift northward toward the tropics. The myrtle beech in the Tarkine is the direct descendant, in the botanical sense, of trees that grew on the ancient supercontinent. The Tarkine survived the last glacial maximum. During the coldest period, the rest of Australia was gripped by drought and cold, and the retreat of forest cover into restricted refugia. The Tarkine was one of those refugia. The high rainfall of the northwest coast, the modifying influence of the ocean, the specific topography of the landscape, kept conditions within the survivable range for the forest species that were sheltering there. They waited out the glacial period in the Tarkine, and when the climate warmed, they expanded from there. This makes the Tarkine a biological archive in the deepest sense. The genetic diversity of the plant and animal species that sheltered there during the glacial maximum is different from the diversity of populations that survived elsewhere. Species that bottlenecked through the Tarkine refugium carry the signature of that bottleneck in their DNA. The forest itself is a record of a survival event that happened over 20,000 years ago. But the Tarkine also contains a physical record of what it survived. Beneath the forest floor, in the layers of organic matter that have been accumulating since the end of the last glacial period, the pollen record tells the story of the forest's expansion. In the waterlogged anaerobic pockets where organic material is preserved, there are the remains of plants and animals from the refugial period, from the time when the forest was at its most contracted and stressed, from the time when the world around it was at its coldest and most hostile. And in the archaeological sites within the Tarkine, there are the traces of the people who also sheltered in the forest during that difficult period. The Aboriginal people of northwestern Tasmania used the Tarkine as a resource base and a refuge just as the plants and animals did. Their sites are in the forest, along the coast, in the rock shelters and cave sites of the region. The earliest of them date to the glacial maximum. The Tarkine has been partly logged and is under ongoing threat from mining. The ground beneath it, the intact organic layers and the sealed cave sites, and the pollen records in the waterlogged forest floor, represents a prehistoric record that, once disturbed, cannot be recovered. It has been accumulating for 20,000 years. It cannot be replaced. Number 12. The Ice Age fauna that left its bones in the dark. Tasmania during the last glacial maximum was a different world. The climate was colder and drier than it is today. The vegetation was different, less forest and more open grassland and tundra-like moorland. And the animal life was different in ways that are still being worked out by the paleontologists who study the sealed cave deposits. Before the last glacial maximum, and during the early period of human occupation, Tasmania had megafauna. Not in the spectacular scale of the mainland, where diprotodons the size of rhinoceroses and giant wombats and enormous kangaroos roamed, but significant animals nonetheless, larger relatives of the animals that survive today, occupying ecological roles that no living Tasmanian animal currently fills. The giant wombat-like diprotodontid, a smaller relative of the massive mainland diprotodon, was present in Tasmania during the Pleistocene. Giant kangaroos, substantially larger than any living species, grazed in the more open parts of the landscape. The marsupial lion, Thylacoleo carnifex, the most powerful predator ever to have evolved on the Australian continent, was present in Tasmania as it was across the mainland. Most of these megafaunal species were gone from Tasmania by approximately 30,000 years ago. The timing of their disappearance is contested, as it is contested everywhere in Australia, and the debate between those who argue for human hunting pressure as the primary cause and those who argue for climate-driven habitat change is ongoing, but they were gone, and their bones were left behind. In the caves of Tasmania, particularly in the limestone cave systems of the northwest and the karst areas of the southwest, Pleistocene megafauna remains are found in the sealed sediment layers below the levels containing Aboriginal occupation evidence. In some caves, the bones are remarkably well preserved, the cold, stable, dark conditions of the cave interior protecting them from the degradation that would have destroyed surface deposits long ago. These bones carry ancient DNA. The technology to extract and sequence ancient DNA from Pleistocene fossil material has advanced dramatically in the last 2 decades, and what was once technically impossible is now routine. Ancient DNA from cave bear bones in European caves has been sequenced. Ancient DNA from mammoths frozen in Siberian permafrost has been sequenced. The same techniques applied to Tasmanian megafauna remains from sealed cave deposits could, in principle, give us the complete genome of the marsupial lion, the Tasmanian diprotodontid, the giant kangaroos that once grazed the island's open grasslands. Some of this work has been done. Not much. The caves are remote, the conditions are difficult, and the funding for paleontological research in Tasmania has never been generous relative to the scale of what is available. But enough has been done to confirm that the ancient DNA is there, preserved in the bone mineral, waiting for the researchers who can extract and sequence it. In the deepest and most sealed of the cave deposits, in the places that have never been entered or that have been entered only briefly and sampled superficially, the record extends back to the time before human beings arrived on the island. To the Tasmania that existed before any person had ever seen it, to the world that was sealed by time and by darkness and by the slow accumulation of sediment, long before any human thought to look. Mid-roll community engagement. I want to pause for just a moment here because I'm curious about something. We've been talking about sealed worlds, about records hidden beneath the surface of an island most people have not thought about deeply, about forests and caves and peat bogs and drowned coastlines and 10,000 years of isolation. And I want to know where you are right now. Not your location in the physical sense, though I am always genuinely curious about that too. I mean, where you are in terms of this material. Is this the kind of history you find yourself returning to? The deep kind, the geological kind, the kind that makes the span of recorded human history look like a single afternoon? Drop a comment. Tell me what surprised you most in the first half of this. Tell me where you're listening from. I read more of those comments than you might think, and they shape what I spend time on in future scripts. Alright, let us continue. Number 13. The Southwest Wilderness and the valleys nobody has entered. There is a section of southwestern Tasmania that does not appear in any hiking guide because there are no hiking tracks that go there. It is not small. We are talking about hundreds of thousands of hectares of terrain in the heart of the Southwest National Park and the World Heritage Area. Terrain that is so rugged, so wet, so remote from any form of infrastructure that systematic human access has simply never occurred. There are peaks in the southwest that were first climbed by humans only in the last few decades. There are valleys that receive so much rainfall, that are so consistently cloud covered, that are so technically difficult to enter and exit, that they have been visited by at most a handful of people in recorded history. What does it mean for a valley to have been visited by a handful of people in recorded history? It means, in the most direct sense, that what is inside it is sealed by geography rather than geology. The cave walls are not doing the sealing. The peat sediment is not doing the sealing. The sheer physical difficulty of getting there is doing the sealing, and the result is the same: intact. In these valleys, the forest floor is undisturbed. The soil profile, the layered record of organic deposition going back thousands of years, has never been broken by a plow or a bulldozer, or even, in most cases, a walking boot. The stream banks have never been stabilized or channeled. The caves, if there are caves, have never been entered. The peat bogs, if there are peat bogs, have never had a core pushed through them. The archaeologists who work in southwestern Tasmania are frank about this. They know that the known archaeological record of the region is a sample, and that the sample is biased toward accessible locations: caves near rivers that can be canoed, rock shelters close to the few tracks that exist, coastal sites that can be reached by boat. The interior, the wet and vertical and inaccessible interior, has been assessed from the air and from satellite imagery, and the assessments consistently suggest that there are cave systems and shelter sites and surface deposits that have never been investigated. This is not negligence. It is simply the reality of working in one of the most challenging environments on Earth with the resources available to Australian archaeology. The southwest is not just remote, it is actively hostile to human presence. The annual rainfall in parts of the region exceeds 3.5 meters. The vegetation is dense and often impenetrable. The terrain is steep and unstable. The weather changes with sudden and extreme severity. People have died there, experienced people who knew the country, simply because the conditions turned against them. But the record is there. In those untouched valley floors, in the undisturbed cave sediments, in the intact peat bogs, there is a record of what happened in that part of the world going back to the first human footfall on the island. A record that has never been read because the people who could read it have never been able to reach it safely enough to do the work properly. For now, those valleys remain what they have always been. Sealed, number 14. The geological anomalies beneath the dolerite. Tasmania's geology is distinctive in ways that have consequences for what might be sealed within it. The most visually striking feature of the Tasmanian landscape is the dolerite. Dolerite is a dark, fine-grained igneous rock that was intruded into Tasmania's sedimentary rock layers approximately 175 million years ago, during the breakup of Gondwana. It forms the dramatic columns and cliffs that define the Tasmanian highlands, the iconic silhouettes of Mount Wellington above Hobart, the blade-like ridges of the southwest ranges, the stepped cliff faces of the Freycinet Peninsula. It is, in a geological sense, the island's skeleton. But beneath the dolerite, and in the areas where the dolerite has not intruded, are sedimentary and metamorphic rocks of much greater antiquity. The Precambrian basement of Tasmania, rocks formed between 600 million and 1 billion years ago, is among the oldest exposed geology in Australia. In these rocks, geologists have found evidence of processes and events that predate not just human history, but the existence of complex life on Earth. The Jurassic dolerite intrusions that created the island's dramatic topography also sealed the rocks below them. In many areas, the dolerite cap acts as a physical seal, protecting the sedimentary sequences beneath from erosion and weathering. In the dolerite-capped highlands, the ancient sedimentary sequences are preserved beneath the igneous cap in a way that would not be possible without it. And within those ancient sedimentary sequences, in the rocks themselves rather than in sediment deposits, there are records of ancient environments that predate anything we have been discussing tonight. Fossilized life forms from the Cambrian explosion, signatures of ancient glaciations that occurred hundreds of millions of years before the last ice age, the chemical signatures of ancient ocean chemistry preserved in the rock mineral structure. These records are not directly relevant to human history, which is what most of this script has been focused on, but they are relevant to the idea of Tasmania as a place where things are sealed and preserved. The geology of the island is conducive to preservation at every scale, from the dolerite cap that seals Precambrian sediments, to the limestone cave chambers that seal Pleistocene bone deposits, to the peat bogs that seal Holocene pollen records. Tasmania is, structurally, a place where things that should have been destroyed by time have instead been kept. That is not an accident. It is a consequence of specific geological and climatic conditions that happen to converge on this particular island, and those conditions have been in operation for a very long time. Number 15. The thermal springs and the heat that comes from below. There are thermal springs in Tasmania. This is not widely known. Tasmania does not have the volcanic geology of Iceland or New Zealand or Yellowstone. It does not have the geysers and hot mud pools that most people associate with geothermal activity. And yet, in several locations across the island, groundwater emerges at temperatures significantly above ambient, carrying chemical signatures that indicate it has been circulating through deep geological formations for long periods of time. The thermal springs of the Florentine Valley are the most studied. Water emerging from springs in the valley floor has been measured at temperatures several degrees above the surrounding groundwater, with a chemical composition that indicates it has been in contact with deep rock formations at depth. The precise origin of the thermal component is still debated. Some researchers attribute it to elevated geothermal heat flow from the Precambrian basement. Others point to chemical exothermic reactions in deep sulfide mineral deposits. The question of where the water is coming from is not merely academic. Thermal groundwater systems circulate through rock fractures and passages over long distances and long timescales. The springs that emerge at the surface are the output end of a system that may extend for tens of kilometers in every direction. The water that emerges in the Florentine Valley may have entered the ground elsewhere in the catchment hundreds or thousands of years ago, and it has been traveling through the rock system ever since. In the passages through which that water travels, the slow movement of mineral-laden water over long periods creates a specific kind of geological formation. Speleothems, the collective term for stalactites, stalagmites, flowstones, and other cave mineral deposits. These formations grow so slowly that a single centimeter of thickness can represent decades or centuries of deposition. They are, within their layered structure, a record of the water chemistry that deposited them, which is itself a record of the surface climate at the time of deposition. Speleothems from Tasmanian caves have been dated and analyzed. The results extend the climate record back, in some cases, more than 100,000 years, across 4 glacial interglacial cycles, across a period that encompasses the entire tenure of modern human beings in Africa, let alone in Australia. In the sealed cave systems, where the speleothems have grown undisturbed for 100 millennia, those records are intact. The layers are unbroken. The chemistry is preserved in the crystal structure of the calcite. They are, in the most literal sense, sealed records of the Tasmanian climate, going back to a time before the island existed in its current form. There are cave systems in Tasmania where the speleothem record has never been sampled, where the formations have grown uninterrupted since before the first human being ever set foot on the island. In the most protected, most remote, most sealed of those systems, the record is as pristine as it was the day it began forming. Number 16. What the traditional knowledge actually says. The Aboriginal Tasmanians were separated from their culture, their language, and their traditional knowledge with unusual completeness. The history of this is one of the most disturbing chapters in Australian colonial history. The Black War of the late 1820s, the forced removal to Flinders Island, where disease and despair decimated the population. The deaths, recorded with clinical detachment in colonial documents, of the last speakers of Tasmanian languages. By 1876, with the death of a woman named Truganini in Hobart, the colonial narrative declared the full-blood Aboriginal Tasmanian extinct. That declaration was wrong in a number of ways, and the Aboriginal community of Tasmania has spent decades asserting its continuity and rebuilding its connections to land and culture. But the interruption to the transmission of traditional knowledge was severe. The unbroken oral tradition that had carried information about the landscape across 42,000 years was fractured in the span of a few decades. What fragments survived? Some were recorded by early observers, amateur ethnographers, and missionaries, and interested colonists who wrote down what they heard before the speakers were gone. These records are imperfect, filtered through the assumptions and biases of people who did not understand what they were hearing, translated imprecisely, stripped of context. But they are something, and something survived in other ways, in the names given to landscape features, in the practices and knowledge that Aboriginal descendants have maintained and are reconstructing, in the patterns of use and avoidance that are visible in the archaeological record, even if the spoken reason for them has been lost. The fragments that survive in early ethnographic records contain references to places and to things that the landscape contains. References to sacred sites and to places where certain things happened, some of which correspond to locations that archaeologists have subsequently found to be significant. References to underground places, to places where the ground speaks or where water comes out warm, to places that should not be entered at certain times or by certain people. Some of these references correspond to known cave sites. Some correspond to geological features that have since been identified and studied. And some correspond to places that have not yet been found, or that have been noted but not investigated, or that lie in the inaccessible interior where no one has gone to look. The traditional knowledge of the Aboriginal Tasmanians, in the fragments that survive, is one of the most significant sources of information about what the island contains and where it contains it, because the people who lived there for 42,000 years knew the landscape in a way that no geologist or archaeologist or soil scientist can replicate. They knew it from the inside, from the accumulated experience of generations of daily life in that terrain. Some of what they knew has been lost, some of it has been sealed as completely as any cave sediment, but some of it persists in the descendants who are working to reconstruct it, in the landscape features that still bear the names the old people gave them, in the places that were significant for reasons that the colonial record noted without understanding. It is a resource that has been underused, undervalued, and in many cases actively suppressed. And it may contain, in some form, the directions to things that Western science has not yet found. Number 17, the modern surveys and what the technology is finding. The technology available to archaeologists and geologists working in Tasmania has changed dramatically in the last 2 decades, and the results of that change are only beginning to be understood. LiDAR, light detection and ranging, is an airborne survey technology that fires laser pulses at the ground from an aircraft and uses the return signals to construct a precise 3-dimensional model of the terrain surface. When LiDAR is flown over forested terrain, the software can filter out the signals that return from vegetation and isolate the returns that came from the actual ground surface. The result is a bare earth terrain model that shows the ground beneath the trees as if the forest had been removed. In other parts of the world, LiDAR has transformed landscape archaeology. In Cambodia, it revealed the extent of the ancient Khmer city of Mahendraparvata, an urban complex far larger than anyone had suspected, hidden beneath the jungle canopy and invisible to conventional survey. In Mexico and Guatemala, it revealed Maya cities and agricultural systems of staggering complexity. In Britain, it has revealed thousands of new archaeological features that were invisible to ground survey. Tasmania has begun to be surveyed with LiDAR. The technology is revealing features in the landscape that were previously unknown, sinkholes and depressions that suggest cave passages beneath, subtle earthwork features in areas where there should be no earthworks, anomalous topographic patterns that correspond to no known geological or vegetation process. The interpretation of these features is ongoing, and the field surveys needed to ground truth them are logistically challenging given the remoteness of the terrain. But the preliminary results are consistent with what the broader archaeological and geological evidence suggests. The visible record is a fraction of what actually exists. Ground-penetrating radar applied to cave floors and sediment sequences can identify subsurface features without excavation. Buried fireplaces show up as anomalies in the radar return. Sealed chambers show up as voids. Organic rich layers show up differently from mineral sediment. In the caves that have been surveyed with GPR, the results have confirmed that the sealed stratigraphy extends significantly deeper than the surface excavations have reached, and that there are features buried beneath the current floor level that have not yet been investigated. Satellite-based synthetic aperture radar can detect subtle changes in ground surface elevation over time, revealing processes like slow subsidence over cave passages. Applied to the karst areas of the southwest, it has identified zones of subsidence that correspond to no known cave system, suggesting that there are voids beneath the surface in areas where no cave entrance has yet been found. Environmental DNA, sampling of cave sediment, peat, and waterlogged soil, can identify the presence of organisms that left no macroscopic trace. A sample of cave sediment can be screened for environmental DNA and return the identities of every plant, animal, fungus, and microorganism whose genetic material is preserved in it. For Tasmanian cave sediments, this means that even a small sample of sealed floor material can theoretically identify species that use the cave. And when the sediment is dated, place those species in the cave at a specific point in time. This technology is being applied to Tasmanian sites, but again, the work is in its early stages. The number of cave sediment samples that have been subjected to environmental DNA analysis is small relative to the total number of sealed sites available. The results from the samples that have been analysed are promising, returning identifications of species whose cave use had previously not been known. The technology is catching up to the scale of what is there. It is not yet caught up. Number 18, Dean Arena and the caves that were saved by the dam decision. When the Franklin Dam decision went the way it did in 1983, when the incoming Hawke government honoured the Conservation Campaign's demand and declared that the dam would not be built, it was presented primarily as an environmental victory. The wild river saved, the wilderness preserved. It was that. But it was also something else, something that has become clearer over the 40 years since the decision. It was the preservation of an archaeological archive of global significance. Dean Arena Cave is one of the sites that would have been flooded. Located downstream from Kutikina on the Franklin River, Dean Arena was excavated in 1982 as part of the emergency assessment of cultural heritage values in the threatened river system. The excavation returned dates of more than 15,000 years and contained the same kind of dense cultural deposit that Kutikina had. Charcoal, animal bone, stone tools, the layered evidence of repeated human occupation across thousands of years. Had the dam been built, Dean Arena would now be sitting at the bottom of a reservoir, its contents sealed not by sediment, but by water, inaccessible and effectively destroyed. Both caves are intact. Both still contain the sealed floor layers that the archaeologists of the early 1980s documented, but did not fully excavate. The materials they contain, the bone, the charcoal, the stone tools, the potential ancient DNA, the potential pollen and phytolith and other microevidence are still in place, still preserved, still available to researchers who have techniques that did not exist in 1982. The value of that preservation compounds over time. Every advance in analytical technology, every new method that becomes available to archaeologists, increases the information that can be extracted from a sealed deposit. The researchers who excavated Kutikina in 1982 could not have sequenced ancient DNA from the bones they found, because the technology did not exist. The researchers who go back to Kutikina today can, and the researchers who go back in 20 years will be able to do things that we cannot currently imagine. This is why the preservation of sealed sites matters so acutely, not just for what we can learn from them now, but for what we will be able to learn from them in the future, with technologies that do not yet exist. A sealed site is a reservation of potential knowledge. Every year it remains intact, the value of that reservation increases. The caves of the Franklin River system are sealed. They are protected within the Southwest National Park and the World Heritage Area, and they are waiting. Number 19. The ice core that does not exist yet. There is a gap in the Southern Hemisphere ice core record that is shaped approximately like Tasmania. Ice cores from Antarctica give us climate records going back hundreds of thousands of years, some of the most detailed and precisely dated long-term climate records available anywhere on Earth. They capture in the layers of annual ice accumulation the signature of temperature, atmospheric composition, volcanic activity, and various other climate-related variables across timescales that make the Holocene, the last 10,000 years, look like a single data point. But Antarctic ice cores do not capture everything. They do not capture the specific regional climate history of the mid-latitudes of the Southern Hemisphere. They record global signals well, but regional signals, the patterns of rainfall and temperature and wind that shape the specific environments of places like Tasmania, are diluted and sometimes invisible in the Antarctic record. What is needed for the regional record is a local high-altitude ice core, a core from a glaciated peak that sits at the right altitude in the right climate zone to have been accumulating ice for long enough to give a meaningful record. Does Tasmania have such a peak? It does not currently have glaciers. The island lost its glaciers at the end of the last glacial maximum, when the climate warmed and the ice retreated. The highest peaks in the southwest, Mount Anne and the Arthur Range and the peaks of the Western Arthurs, were extensively glaciated during the glacial maximum, and the landscape still bears the unmistakable marks of that glaciation. The cirques, the moraines, the overdeepened valley floors, the erratic boulders, but the ice itself is gone, except in one particular respect. In several of the deep cirques on the highest southwest peaks, in hollows that are north-facing in configuration but sheltered enough that ice can persist, small patches of permanent or near-permanent snow and ice have been documented. These are not glaciers, they are not ice caps. They are small bodies of compacted snow and ice in topographic hollows, remnants of a much larger system, maintained only in the most sheltered locations. Some of these patches are ancient. The ice at the bottom of a persistent snowfield, the ice that has been there the longest, can be very old indeed, particularly if the annual melt does not reach the base. It has never been cored. It has never been sampled to determine its age. The probability that these small ice bodies contain climate records going back to the late Pleistocene is not high. They are small, and the glaciological conditions are not ideal for long-term preservation, but the probability is not zero. And in the absence of a proper survey and sampling program, we simply do not know. What we do know is that the landscape around these ice patches holds a detailed record of the glacial history of the Southwest. The geomorphology, the shape of the land surface as sculpted by the glaciers, is a physical record of the extent and duration of the ice. The till deposits, the unsorted sediment left behind by retreating glaciers, can be dated. The lakes in the cirque basins contain sediment records going back to the deglaciation. All of this material is sealed, to varying degrees, by the remoteness of its location and by the difficulty of accessing the highest terrain in the southwest, and the record it contains predates the human occupation of the island by a significant margin. The glacial geomorphology of the southwest began forming before any person was in Tasmania. It was there before the first human eyes ever looked at it, and it is still there, shaped into the landscape, sealed into the sediment. Number 20. The sealed coastline and what the sea preserved. There is a coast in Tasmania that nobody has ever stood on. Not in the dramatic sense, not a coast that is physically unreachable, though some of the southwest coast comes close. I mean, a coast that no longer exists above the waterline. The coast that existed 10,000 years ago when the sea level was lower and the island was larger. The coast where the people who became isolated walked down to the water and looked out at a vast strait that was still partly land. When the sea rose at the end of the last glacial maximum, it rose slowly by geological standards, but rapidly by human standards. The change was measurable within a generation, perceptible within a lifetime. The people living on the coast during the period of rising sea level would have seen specific beaches and coves and headlands that they knew from childhood disappear beneath the water. The coastal sites of the Aboriginal Tasmanians from the early post-glacial period are therefore mostly gone. Submerged, the middens, the accumulations of shellfish remains, and other food debris that mark long-term coastal occupation sites, the campsites on beach dunes, the rock shelters and caves at coastal headlands. All of the sites that were occupied when the sea level was lower are now underwater. This is not unique to Tasmania. It is a global problem in coastal archaeology. An enormous proportion of the human occupation sites from the period between approximately 15,000 and 8,000 years ago are underwater somewhere around the world. The archaeology of the early post-glacial coastline is, almost everywhere, a submerged archaeology. But in Tasmania, the submerged coastline has a specific additional significance, because the coast that was submerged was the coast of an island in the process of becoming an island. The period of rising sea level corresponds to the period of increasing isolation. The sites from this period, if they could be found and excavated, would show the transition from a connected to an isolated human population. They would show what resources were being used, what technologies were employed, what the population size and distribution looked like during the critical period when the Bass Strait was forming, and the Tasmanian people were becoming the isolated culture they would remain for 10,000 years. Those sites are out there, somewhere on the continental shelf, south of the Bass Strait, and around the Tasmanian coast. They are sealed under water and under marine sediment, and under whatever biological growth has colonized the seafloor in the millennia since they were occupied. They are not accessible with current Tasmanian archaeological resources. They have not been found and not been sampled. But the preservation conditions for coastal shell middens are not bad. Shell resists decomposition. Bone preserved in anaerobic marine sediment can survive for extraordinary periods. Charcoal from submerged hearths has been dated at other submerged sites around the world. The record exists. It is just sealed beneath the Tasmanian Sea. And the sea is very cold and very deep, and the island above it keeps its secrets very well. Number 21. The question. Nobody is asking about the sealed chambers. There is a question that sits at the center of everything we've discussed tonight, and I want to spend some time with it before we come to the end. We have talked about caves that have never been entered, cave floors that have never been touched, peat bogs that have never been cored, drowned coastlines that have never been surveyed, valley floors that have never been walked. The question that most people ask when confronted with this material is, what is in there? That is a good question. It is the obvious question, and we have talked about some of the probable answers. Ancient DNA, undated archaeological deposits, climate records going back beyond the range of anything currently known, the bones of extinct animals, the traces of human lives lived in conditions of complete isolation for tens of thousands of years. But the question I find more interesting is a different one. It is, what would it mean if we could read all of it? Because the sealed records of Tasmania are not just a collection of individual archaeological or geological discoveries waiting to happen. They are, taken together, something more significant than the sum of their parts. They are a continuous record, an unbroken account, of what happened on a specific piece of land across a span of time that encompasses the entirety of everything that most of us consider to be human history, and extends far beyond it in both directions. The 42,000 years of human occupation in Tasmania represents one of the longest continuous records of human adaptation to a single landscape available anywhere on Earth. The specific conditions of the island, the isolation, the preservation, the geology, have combined to create a situation where that record is extraordinarily well preserved and extraordinarily little disturbed. If we could read it fully, if we could extract the information from every sealed cave, every intact peat sequence, every drowned coastal site, we would have a picture of human life across 42,000 years that exists nowhere else. A picture that would answer questions about how human populations respond to long-term isolation, how traditional knowledge systems encode environmental information across millennia, how climate change at the end of the glacial period affected a human population in real time, what the biodiversity of a temperate island looked like before industrialization, and dozens of other questions that currently have only partial or indirect answers. That is what is sealed beneath Tasmania. Not treasure in the conventional sense, not gold or artifacts or spectacular monuments. Something more fundamental and, in the long run, more valuable. A record, an archive, a continuous account of 42,000 years of human and biological and geological history, encoded in bone and charcoal and pollen and crystal and tree ring and peat and cold dark silence. It is older than Stonehenge by the age of everything Stonehenge has ever witnessed, and it is still there. Number 22. The scientists who are trying to read it, They are few, and their funding is limited, and the terrain is hostile, and the logistics are expensive. But they are there. The paleontologists who work the cave sites in the Mole Creek karst and the limestone systems of the northwest spend weeks at a time in difficult cold conditions, extracting material from sealed sediment layers 1 centimeter at a time and sending it for analysis to laboratories that are often months away from returning results. The dates that come back, when they come back, are often surprising. A sealed layer that looks close to the surface turns out to be deeper in time than expected. A bone that looks like a fairly recent animal deposit turns out to be from the Pleistocene. The paleoecologists who pull sediment cores from Tasmanian lakes and peatlands work in watercraft on dark, cold, remote water, pushing metal tubes into lake beds and pulling up columns of sediment that represent, centimeter by centimeter, thousands of years of accumulated history. Back in the laboratory, those cores are subsampled at intervals, and the samples sent for pollen analysis, charcoal analysis, diatom analysis, radiocarbon dating. The results build up slowly into pictures of environments that no living person has ever seen. The archaeologists who survey the known cave sites and argue for the resources to investigate the unknown ones work within a bureaucratic and funding structure that is, by any assessment, inadequate to the scale of what needs to be done. Australian archaeology is chronically underfunded relative to the significance of the record. The sites that are known and documented are a fraction of what almost certainly exists. The Aboriginal community members who are engaged in the cultural heritage assessment and protection of Tasmanian sites bring a different kind of knowledge to the work, one that is not easily quantified or cited in peer-reviewed publications, but that is real and significant. The knowledge of which places were important and why, even when the specific content of that knowledge has been interrupted by the colonial period, contains information about the landscape that Western scientific survey has not recovered, and may not recover independently. These people are all working toward the same thing, though they approach it from different directions and sometimes in tension with each other. They are trying to read the archive, they are trying to understand what is sealed beneath Tasmania and what it means. It is slow work. It will take generations to do properly, if it is done at all. The rate at which new knowledge is generated is modest relative to the scale of what is available. But it is being done, and the things that are being found in the sealed caves and the drowned coastlines and the cold lake beds are worth finding. Number 23, the lake that has not been cored yet. There is a lake in southwestern Tasmania, deep in the World Heritage Area, that sits in a glacially carved basin surrounded by dolerite peaks. It receives several meters of rain a year, it is very cold, it is very remote, there is no track to it. Getting there requires either a multi-day walk through country that will test the fitness of most experienced hikers, or a helicopter, and in the southwest, the weather makes helicopter access unreliable. The lake has a name on the map. It is known to the small community of people who walk in that part of the world. It has been photographed from the air and from the tops of the surrounding ridges by the rare people who have climbed them. Its sediment has never been cored. There is no particular reason to single this lake out over the many other lakes in the southwest that are in the same situation. I am not suggesting that this specific lake holds something that others do not. I am using it as a concrete representation of an abstract problem, the gap between what exists and what has been investigated. The sediment at the bottom of that lake began accumulating at the end of the last glacial period, when the ice melted from the Cirque Basin and water collected in the depression the glacier had carved. For approximately 10,000 years since the ice retreated, pollen has been falling from the surrounding vegetation into the lake surface, and settling through the water column, and coming to rest on the lake floor, and being gently buried by the next year's accumulation. The record is continuous. Each year adds another layer. Each layer is precisely dated relative to the one above it and the one below. The pollen in those layers represents the vegetation of the surrounding catchment at the time the pollen was produced. Changes in vegetation composition are visible as changes in the pollen assemblage. Fire events are visible as peaks in microscopic charcoal. Human activity in the catchment, if there was any, is visible as a combination of increased fire frequency and shifts in the pollen assemblage that correspond to the opening of the vegetation by human burning. The lake almost certainly records the human history of its catchment. Whether people visited it, whether they camped beside it, whether they lit fires in the valleys above it, all of this would show up in the pollen and charcoal record of the sediment core. Nobody knows yet. The core has not been taken. The record is sealed in the cold, dark water, patient in the way that geological things are patient, undisturbed by anything that has happened in the world above since the day the last glacier melted and the rain began to fall. It is waiting. Number 24. What happens when the archive is disturbed? We have been talking about what is sealed. It is worth spending some time on what has already been lost, and what that loss tells us about the urgency of the sealing that remains. Tasmania has not been uniformly preserved. The eastern and northern parts of the island, where European settlement was concentrated, and where the land was cleared earliest and most extensively, have lost most of their archaeological record. The cave sites in accessible areas near early settlement were disturbed or destroyed before anyone understood their significance. Middens were used as road fill, sites were ploughed, artifacts were collected without documentation. This is not a story unique to Tasmania. It is the global story of archaeological heritage in the post-colonial period. The loss is real and it is irreversible. What was sealed in those sites, what was held in those sealed floor layers and midden deposits and cave sediments, is gone. It cannot be recovered. The information it contained, the record it preserved, was destroyed in the period before the tools existed to read it and before the understanding existed to value it. The reason that the sealed record in the inaccessible Southwest matters so much is precisely because it is the complement to the record that has been lost elsewhere. The eastern and northern sites are disturbed. The accessible caves have been sampled, sometimes destructively. The coastal sites near settlement are compromised. The Southwest, protected by its very inaccessibility, has retained what was destroyed elsewhere. The Southwest is not just important in itself, it is the backup. It is the part of the archive that survived the events that destroyed the rest, and it survived not because of any deliberate act of preservation, but because it was simply too far away and too difficult to reach for the destruction to get there in time. The World Heritage Listing of the Southwest, which occurred in 1982 and was extended in subsequent years, provides legal protection for the archaeological and natural heritage of the region. The Southwest National Park protects the land from direct development. These protections are real and they matter, but they are not absolute. Mining proposals, forestry operations, and infrastructure developments have repeatedly challenged the boundaries of the protected area. Each challenge is assessed individually, and each assessment must balance the economic interests of the development against the heritage values of the site. In a context where those heritage values are imperfectly understood because the research needed to quantify them has not been done, the assessment is inherently incomplete. What we do not know about the Southwest is an argument for protecting it, not for developing it. An archive whose contents have not yet been catalogued is not an archive of known and quantifiable value. It is an archive of unknown and potentially extraordinary value. The appropriate response to unknown value is not to destroy it. It is to protect it until the research needed to understand it has been done. That principle is not consistently applied. The history of the Southwest includes examples of heritage destruction that occurred before the heritage was understood, and of near misses like the Franklin Dam, where the destruction was averted only by a political campaign of unusual intensity. The record that is still sealed is the record that remains to be protected, and the urgency of that protection is not abstract. It is the urgency of an archive that has survived 42,000 years of natural processes and several decades of colonial presence, and that could be compromised or destroyed by a single decision made by people who have not yet understood what they are deciding about. Number 25. The Paleogenomics revolution and what it could find in Tasmania. There is a revolution happening in our ability to read the past, and it is moving faster than most of the public understands. Ancient DNA, the genetic material preserved in the bones, teeth, sediment, and other organic remains in archaeological and paleontological sites, has become readable in extraordinary detail over the last 15 years. The technical problems that seemed insurmountable in the early 2000s have been solved one after another by improvements in sequencing technology, in computational methods, and in the chemistry of DNA extraction. What was once possible only for the most exceptionally well-preserved specimens, frozen mammoths, perfectly dried desert mummies, is now achievable from the degraded bone fragments in a temperate cave deposit. The implications for what is sealed beneath Tasmania are significant. In the cave sediments of the Southwest, there are human remains. Not many, not the rich burial deposits of some world regions, because the cultural practices of the Aboriginal Tasmanians did not typically involve cave burial in the way that some other cultures do. But incidental remains, a tooth lost from a person who slept in the cave, a fragment of bone from a burial nearby, hair preserved in the sediment, these are present in the deeper layers of the known sites, and they are almost certainly present in the sealed sites that have not yet been investigated. The ancient DNA in those remains, if it can be extracted and sequenced, could provide extraordinary information. The genetic history of the Tasmanian population across 42,000 years, the population size and diversity at different periods, the genetic signature of the isolation that began 10,000 years ago, the relationship between the early Tasmanians and the populations from which they descended, the genetic evidence for whether there was any contact with the mainland after the Bass Strait formed, or whether the isolation was as complete as the geographical and cultural evidence suggests. This is not speculative. The tools exist. The questions are real. The material, if it is where the probability calculations suggest it should be, is there. The ancient DNA from megafaunal remains in the sealed cave deposits offers a different set of possibilities. The complete genomes of extinct Tasmanian species, the thylacine in the historical population, the marsupial lion in the Pleistocene deposit, the giant wombat relatives in the glacial maximum layer, could theoretically be sequenced from well-preserved material in the sealed cave floors. For the thylacine in particular, this is not theoretical. Museum specimens of historical thylacines have already yielded partial genome sequences. Complete genomes from well-preserved cave material would be a significant advance. The environmental DNA in the peat sediments, the microscopic traces of genetic material shed by every organism that lived in or passed through the area, adds another dimension. A column of peat sediment from the southwest could theoretically be screened for the environmental DNA of every plant, animal, fungus, and microorganism that left a genetic trace in that environment across the period covered by the sediment column. The resulting inventory would be a biodiversity record of extraordinary completeness and temporal resolution. None of this has been done at scale in Tasmania. The work is beginning. The results that are coming back from the pilot studies are encouraging, but the coverage is minimal relative to the total material available in the sealed sites. The revolution in paleogenomics is real, and it is still gathering speed. Every year, the tools get better, the methods get cheaper, and the amount of information that can be extracted from a given amount of ancient material increases. The sealed deposits of Tasmania will be more legible in 10 years than they are now, and more legible still in 20. The value of keeping them sealed until the tools can read them properly is compounding in real time. Number 26, the oldest living ecosystem on Earth. There is a claim that is sometimes made about Tasmania that sounds like an exaggeration, but is, on examination, closer to the truth than most extraordinary claims. The claim is that southwestern Tasmania contains the oldest intact living ecosystem in the world. What does that mean, and is it true? An ecosystem is not a single organism. It is a web of relationships between organisms and their physical environment, and between the chemical and geological processes that underlie everything. An ecosystem can be described as intact if the web of relationships that defines it has not been fundamentally disrupted, if the species that compose it are still present, if the processes that connect them are still operating, if the physical environment that underlies them has not been dramatically altered. In southwestern Tasmania, the ecosystem that exists today has a lineage, in the biological sense, that extends back to the Gondwana period. The myrtle beech, the dominant tree of the rainforest, is a direct descendant of Gondwana flora. The relationships between it and the fungi that colonize its roots, the mosses that grow on its bark, the insects that feed on its leaves, and the animals that shelter in its hollows are relationships that developed in a Gondwana context and have persisted through the separation of the continents, through the ice ages, through everything. That is not the same as saying the ecosystem is unchanged. It has changed. Species have evolved, gone extinct, and colonized from elsewhere. The climate has shifted dramatically multiple times. The Aboriginal people of Tasmania shaped the ecosystem through 42,000 years of fire and hunting and movement through the landscape. All of this happened, and the ecosystem absorbed it and continued. But the fundamental structure, the web of Gondwana-derived relationships, the deep ecological architecture of the southwest, has persisted. It is older, in the lineage sense, than any other intact temperate ecosystem on Earth. The only competitor of comparable antiquity is the Valdivian temperate rainforest of southern Chile, which shares the same Gondwana origin and has been similarly isolated by geography and climate. In the soil of this ecosystem, in the cold, wet, acidic organic layer that covers the ground of the Tarkine and the rainforests of the southwest, there are organisms that have been present in that landscape since before the continent separated from Antarctica. Fungi, whose mycorrhizal relationships with the myrtle beech predate the existence of Australia as a separate landmass. Mosses, whose lineages extend back to the Cretaceous. These organisms are not sealed in a cave, they are alive and growing on the surface. But the soil beneath them, the layer of accumulated organic material in which they grow, is as much an archive as any cave sediment. It encodes, in its chemistry and its biology and its physical structure, the history of the ecosystem that built it. That soil has been accumulating in the southwest since the ice retreated. In the most undisturbed areas, it is intact. The organisms that built it are still living in it. The processes that created it are still operating. It is, in that sense, the oldest living archive on Earth. Number 27. What 10,000 years of isolation does to a culture. We have circled around this topic throughout the script, and it is time to look at it directly, because the question of what happened to the culture of the Aboriginal Tasmanians during their 10,000 years of isolation is one of the most contested and most important questions in Australian anthropology, and the sealed record beneath the island is one of the few sources that can give us a direct answer. When European contact began in the late 18th century, observers noted aspects of Tasmanian Aboriginal culture that seemed, by comparison with mainland Aboriginal cultures, unusual. The Tasmanians did not eat scale fish, which was puzzling to observers who noted the abundant fish in Tasmanian waters. They used a simpler toolkit with fewer distinct tool types than mainland Australian groups. Their use of fire-making technology was apparently different. They lacked certain technologies that mainland groups had. The early European interpretation of these observations was, by modern standards, profoundly problematic. It was filtered through the racial hierarchies of 19th century thought, and it produced assessments that we now recognize as racist and incorrect. But the observations themselves, stripped of the interpretive framework that distorted them, raised a real question that subsequent researchers have worked hard to answer. The archaeological record provides some answers. The early layers of Tasmanian cave sites, dating to the period before the formation of the Bass Strait, contain a range of tool types and subsistence evidence broadly comparable with contemporary mainland sites. Over time, the Tasmanian record shows changes. Not a consistent decline, but changes. Some tool types appear and others disappear. The subsistence base shifts, the spatial distribution of sites changes. Some researchers have interpreted this as evidence of cultural simplification under isolation. Without the stimulus of contact with other groups, without access to innovations from elsewhere, the argument goes the Tasmanian toolkit contracted. Other researchers have argued vigorously against this interpretation. They point out that what looks like simplification from a tool counting perspective may represent adaptation and innovation in non-material aspects of culture that leave no archaeological trace. A group that invests more heavily in knowledge, in ceremony, and social relationships may appear archaeologically poorer than a group whose adaptations are more materially visible. The absence of a tool type from the archaeological record does not necessarily mean the people had simplified. It may mean their innovations were in domains that do not preserve. The debate is not fully resolved. The archaeological record is insufficient to give a definitive answer, partly because the record is incomplete, and partly because the questions being asked are genuinely difficult to answer from material evidence alone. The sealed cave sites of the southwest, if fully investigated, would contribute substantially to this debate. A complete record of cultural material from sealed, undisturbed deposits across the full 42,000-year sequence would allow researchers to trace the cultural changes over time with far greater resolution than is currently possible. The spatial distribution of sites across the landscape, the composition of the faunal assemblages, the technological attributes of the stone tool assemblages, all of these would be visible in the intact deposits in a way that is not visible in the partially excavated, partly compromised sites that currently form the bulk of the record. The answer is in the ground. It has been in the ground for 42,000 years. We have sampled enough to know the question is answerable in principle. We have not sampled enough to answer it. Number 28. The sound of the cave. There is something that does not get discussed much in the scientific literature because it does not fit neatly into the frameworks of archaeology or geology or paleoclimatology. But it is real, and it is part of the story. The Aboriginal people who used the caves of southwestern Tasmania for 42,000 years were not just using them for shelter, they were living in them in a much fuller sense. They were having conversations in those caves, they were telling stories, they were possibly singing. The acoustic properties of a limestone cave, the way it carries and reverberates and transforms sound, were known to the people who used it. They had been known for generations beyond counting. The cave was not just a physical shelter, it was a sonic environment, and the people who inhabited it had a relationship with its sound as they had a relationship with everything else about it. This is true of caves across the world. Researchers studying the relationship between acoustic properties and the location of cave art in painted caves in Europe have found a non-random relationship. Painted panels tend to be located in parts of caves that have distinctive acoustic properties, places where sound resonates or amplifies or transforms in specific ways. The people who painted those caves appear to have been deliberately placing images in locations where the sound of the cave was meaningful. We do not know if the same relationship holds in Tasmanian cave art sites. The research has not been done. But the probability that the people who used those caves for 42,000 years had an acoustically informed relationship with the space is not small. It is the kind of knowledge that develops over long periods of intimate engagement with a place. The sound of a sealed cave, the specific acoustic environment of a chamber that has been closed for a long time, is different from the sound of an open or frequently visited space. There is a stillness to it that is almost physical. The absence of the small sounds that characterize inhabited spaces, the creak and settle of living things, the passage of air through openings, creates something that is hard to describe but immediately recognizable to anyone who has been in a truly sealed cave. That is the sound of the oldest parts of the Tasmanian record. Silence. The silence of a space that has been undisturbed for 10,000 years, or 20,000 or more. It is not an absence, it is a presence. The accumulated stillness of all the years since the last person left. And in that silence, the physical record waits. Patient in the way that only very old things can be patient, unchanged, intact, holding everything it was given to hold for as long as the seal holds. Number 29, the world before the world we know. One of the things that this material does to a person, if you stay with it long enough, is change the scale at which you perceive time. 5,000 years feels like a long time until you're talking about 42,000. Written history feels permanent until you're holding a piece of charcoal from a fireplace that is 30,000 years older than any written language. The great monuments of human civilization, the pyramids, the temples, the cathedrals, feel imposing until you stand at the mouth of a cave where people slept 19,000 years ago, in a world so different from ours that the plants and animals and climate were all different, and the sea was somewhere else, and there was ice where now there is open water. And in the firelight, the shapes of the people who were there, the hands and faces, were the same shapes as the people who are here now. That is what the sealed record of Tasmania ultimately points to. Not just data, not just archaeological samples and sediment cores and radiocarbon dates. A different relationship with time. A recognition that the world as it is now is an extraordinarily recent arrangement of things that have been arranged many other ways before, and that the record of those other arrangements is not lost, is not gone, is not inaccessible in principle. It is there, under the ground, under the cold water, in the dark behind the cave wall. The oldest things are often the most durable. A bone sealed in limestone sediment will outlast every building currently standing on Earth. A pollen grain trapped in peat will remain identifiable and datable long after the city that processed the core sample has ceased to exist. The Gondwana lineage of a myrtle beetroot system will persist in the southwest Tasmanian soil, long after the human disputes about its management are resolved and forgotten. Time in Tasmania is not a story of loss. Or not only that, it is also a story of preservation, of sealing and containing and holding. The island has functioned for tens of thousands of years as a vault. The conditions, the cold, the wet, the acid, the dark, the remoteness, have conspired to keep things that would elsewhere have been destroyed. The karst preserved the bones, the peat preserved the pollen, the cold dark water preserved the wood, the isolation preserved the culture. The World Heritage designation, arrived at long after all of this, is in some sense just the legal recognition of a process that the island itself had been conducting since the end of the last ice age. What is sealed beneath Tasmania is a record of the world before the world we know. The world before cities, before writing, before agriculture, before the long accumulation of human infrastructure that has reshaped every other piece of land on the planet. The world in which human beings and the landscapes they inhabited were in a different kind of relationship, a relationship of dependence and adaptation and long, slow learning. That world still exists, in the dark beneath the island. It is not gone. It is waiting. Number 30, the question at the end of everything. We are near the end now. The fire, if there is a fire where you are, will be lower. The day will be further gone. The darkness outside will be a little more complete. I want to end with a question rather than a summary, because I think it is a better fit for the material. The question is this: what do we owe to a record? Not to the people whose record it is, though that is a different and important question to which there are clear answers, but to the record itself. To the 42,000 years of accumulated evidence that sits sealed beneath the ground of an island, most of the world does not think about very often. To the pollen grains and the charcoal fragments and the sealed cave floors and the drowned coastlines and the peat bogs and the old cold wood. What do we owe to the fact that it exists, that it has survived, that it is there, available in principle, holding information that we are only beginning to have the tools to extract? One answer is nothing. Records do not have moral standing. The sediment does not care whether it is read or not. The cave does not suffer if no one enters it. The peat bog loses nothing by remaining uncored. On this view, the obligation we might feel toward the Tasmanian archive is sentimental rather than ethical. But I think there is another answer, and it is an answer that has to do with the relationship between the present and the future. The reason to preserve a sealed archive is not for the benefit of the archive. It is for the benefit of the people who will come later. The people who will have better tools, better questions, better frameworks for understanding what the archive contains. The people who, 50 years from now, or 100, will be able to extract from a single gram of cave sediment an amount of information that we currently cannot imagine. The people who will, in their own present, feel the same pull toward the deep past that we feel now. Those people will only be able to access that information if the archive is still intact when they get to it, if the seal holds. If the cave floor has not been disturbed, the peat bog has not been drained, the drowned coastline has not been dredged, the World Heritage boundary has not been revised to allow a mine. What we owe the archive is protection, not forever, not at the cost of every other consideration, but the kind of serious, sustained, legally backed protection that recognizes the value of something that cannot be recreated once it is gone. The sealed record of Tasmania is the result of 42,000 years of natural preservation and 10,000 years of geographic isolation. It is, by the standards of geological time, extraordinarily recent, and by the standards of human history, it is extraordinarily old. It is both of these things at once, and it is still there, and if we are careful enough for long enough, it will still be there for the people who come after us, who will read it better than we can. That, in the end, is what is sealed beneath Tasmania. A gift that was not intended as one. An archive that survived by accident, and a question about what we will do with it now that we know. Number 31. The Bone Cave discoveries that changed the dating. In 2012, a team of researchers working in the Maxwell River cave system in northwestern Tasmania extracted a series of sediment cores from a sealed section of a cave floor that had not been previously investigated. The team was small, the conditions were difficult, and the results took months to process. When the radiocarbon dates came back, they changed the established understanding of the region's faunal history. The deepest levels of the sealed section returned dates of more than 41,000 years. At those depths, the bone assemblage included the remains of species that had not previously been confirmed at such ages in Tasmania, including a large macropod, a member of the kangaroo family, that was substantially larger than any living Tasmanian species, and that bore morphological characteristics intermediate between known mainland Pleistocene species and the smaller modern Tasmanian forms. The implication was significant. If the dates and the identifications held, it suggested that the Tasmanian fauna at the time of first human arrival was more diverse and included larger-bodied species than the existing record indicated. And the timing of their disappearance from the record, visible in the cave stratigraphy as an absence that coincides roughly with the period of earliest human occupation, placed their extinction in a context that had direct bearing on the debate about human versus climate causes of the Pleistocene megafaunal extinction. This single cave, in a remote part of the northwest that very few people have visited, produced a result that required a reconsideration of existing frameworks. Not a dramatic overturning, not a revolution in a single paper, but a genuine complication of the picture. The kind of complication that happens when you look carefully at sealed material in a place that has not been carefully looked at before. The researchers noted in their publication that the cave system extended significantly beyond what they had investigated, and that sealed sections of greater depth and potentially greater age were present but not yet sampled. They made the standard academic call for further investigation. That call, as academic calls often do, went largely unanswered for want of funding. The deeper sections of that cave system are still sealed. Whatever is in them, at depths corresponding to ages that might push the faunal and human occupation records even further back than the 2012 study indicated, is still there. This is how Tasmanian archaeology works, not in grand revelations, but in incremental adjustments, each one requiring a recalibration of what was previously understood, each one pointing to further material that remains uninvestigated. The picture builds slowly through the work of small teams in difficult terrain with limited resources, and each addition to the picture makes the existing gaps more visible, not less. The sealed caves of Tasmania are not a problem to be solved in a single expedition. They are a research program of generational scope, the kind that requires sustained institutional commitment across decades. What makes them worth that commitment is precisely their completeness. An uninterrupted record, starting from the beginning of human presence in Australia and running to the present, sealed against disturbance, waiting to be read. No single cave will give you the whole picture, but enough caves, carefully investigated across enough of the island's geography, might give you something that no other place on Earth can offer. A complete story. Number 32. The Aboriginal names that encode geological memory. Language carries more than communication, it carries knowledge. And in languages that have been developed in relationship with a specific landscape over very long periods of time, the knowledge encoded in the names of places can be extraordinarily precise. The Aboriginal languages of Tasmania were numerous. Linguists have identified multiple distinct language groups across the island, with significant variation in vocabulary and grammar between them. By the time systematic attempts at documentation began, most of these languages had already lost the majority of their speakers, and the records that survive are fragmentary and imperfectly understood. But in what has survived, there are names for landscape features that encode observations of those features made over very long periods of time. Names that describe the behavior of water, the quality of stone, the presence of particular plants or animals, the specific dangers and affordances of particular places. Names that are, in effect, compressed ecological and geographical knowledge passed down through generations. Some of these names describe features whose significance is geological. Certain places are named in ways that suggest awareness of processes that geology has subsequently confirmed. Locations associated with underground water, with places where the ground subsides, with places where heat or gas emerges from the earth. The oral tradition, in the fragments that survive, refers to events that geological analysis can now date. Landslides, floods, volcanic events that occurred in the geologically recent past but before European contact. The most significant of these, from the perspective of the sealed record, are the references to landscape change. There are named places in the Tasmanian Aboriginal record that describe topographic features which no longer exist, or which exist now in significantly modified form. Features that may have been present at a much earlier period of the landscape's development. The geological and geomorphological analysis needed to check these references against the physical record has not been done comprehensively. In some cases, the names refer to places that are now underwater. The rising of the Bass Strait and the other post-glacial sea level changes that reshaped the Tasmanian coast would have been within the oral tradition of a culture that was already many thousands of years old when those changes occurred. The people who saw those coastlines disappear would have named them, talked about them, incorporated them into the stories that carried knowledge across generations. Whether any of that knowledge survives in the fragments of the Tasmanian languages that have been documented is a question that the existing linguistic records are insufficient to answer definitively. The documentation that was done imperfectly by people who did not understand the significance of what they were hearing. The speakers who were asked to provide vocabulary and phrases were not always asked the questions that would have elicited the most informative answers. The Aboriginal community in Tasmania is working on language revitalisation, drawing on the imperfect records that survive and on the knowledge that was passed down even through the interruptions of the colonial period. That work is not just cultural, it is, in a real sense, archaeological, because every fragment of language that is recovered and understood is a potential key to something that is sealed in the physical landscape, waiting for the right question to open it. Number 33, the deep water lakes and what the sonar found. In the 1990s, a team of researchers conducting bathymetric surveys of several deep lakes in southwestern Tasmania encountered something in the sonar data that they did not immediately understand. On the floor of one of the lakes, at a depth that placed it well below any recent depositional activity, the sonar profile showed a series of anomalous features. Linear structures, distributed in a pattern that was not consistent with the known geological processes that formed the lake. Not dramatic structures, not the kind of thing that produces headlines. Subtle features in the sonar return that differed from the surrounding lake bed in a way that suggested they were made of different material or were arranged in a different orientation. The researchers noted the anomalies, recorded their position and extent, and included a brief description in their survey report. They did not have the resources or the mandate to investigate further. The report was published, cited occasionally, and for the most part did not generate follow-up investigation. What were the features? Several hypotheses were advanced. Pressure ridges formed by sediment compaction, differential deposition patterns caused by deep water currents, biological structures created by organisms living on the lake floor, the possibility that the features were anthropogenic, that they were the remains of something made by people, was mentioned in the discussion section of the report as a low probability but non-eliminable hypothesis, given the known antiquity of human occupation in the surrounding landscape and the likelihood that the lake shoreline had been used as a resource base during drier periods when the lake level was lower. No one went back to look more carefully. The lake is remote. Diver access to the depths where the features were recorded is technically demanding and logistically expensive. The features themselves, as described in the report, do not represent sufficient evidence of significance to justify the cost of a proper investigation without further supporting evidence. They remain unexplained. Probably they are natural. The probability of the most dramatic interpretation is, by any honest assessment, low. But the probability is not zero, and in the absence of investigation, it cannot be reduced further. The sonar data sits in the research archives, and the lake floor sits in the cold, dark water, and the anomalous features, whatever they are, remain exactly as they were when the sonar found them. This is the nature of the Tasmanian record. It offers, consistently, things that are interesting enough to be worth investigating and not yet clear enough to be understood. It rewards patience and repeated return. It does not offer certainty. But it keeps presenting material that suggests the complete picture is larger than the current picture, and that the difference between the two is sealed somewhere under the water or the sediment or the stone. Number 34. The question of fire. 42,000 years of burning. Of all the things that the sealed archive of Tasmania can tell us, one of the most important is the story of fire. Human beings use fire. They have always used fire. It is one of the distinguishing characteristics of the species, one of the capabilities that makes human ecological impact visible in the landscape record in a way that no other animal leaves it. When people come to a new landscape, fire comes with them. The charcoal record changes, the pollen record changes, the vegetation composition shifts, the frequency of burning events increases. All of this is visible in the sealed sediment. The Aboriginal Tasmanians used fire extensively and intentionally. Fire was a tool for managing the landscape, for opening up vegetation, for promoting the growth of food plants, for creating habitat for game animals, for signaling, for warmth, for ceremony. The relationship between Aboriginal land management and fire is now well established in Australian environmental history, though the full implications of it are still being worked through. In Tasmania, the sealed peat and lake sediments record this fire history with unusual completeness. A core from the right location, covering the right time period, can show you not just that fires occurred, but approximately how frequent they were, how intense they were, inferred from the size of charcoal particles and the proportion of fine to coarse material, and how the vegetation responded to them over time. The cores that have been taken from Tasmanian sediments show a clear signal of increased fire frequency beginning approximately 42,000 years ago, coinciding with the archaeological evidence of first human arrival. Before that, fire events occur, because lightning strike fires are a natural feature of any landscape. But the pattern changes at the point of human arrival. The frequency increases, the spatial distribution shifts. The relationship between fire and vegetation composition changes in ways that suggest deliberate management rather than random ignition. This signal is one of the best documented pieces of evidence for the antiquity of Aboriginal land management practices in Australia. It is a record of intentional human action encoded in the chemistry of sediment that was accumulating quietly in the dark while the fires were burning above it 42,000 years ago. But the full record has not been read. The cores that have produced this evidence are a sample of what is available. In the sealed peat bogs and lake sediments of the unexplored southwest, the record extends further and in greater detail than the current sample can show. The specific patterns of burning, the seasonal timing, the geographic distribution, the response of the vegetation to different burning intensities. All of this is encoded in the sealed sediment, available in principle to the researchers who can reach it. The story of fire in Tasmania is also the story of the relationship between people and their landscape. The landscape that Europeans encountered when they arrived in Tasmania was not a natural landscape in the sense of a landscape shaped only by non-human processes. It was a cultural landscape shaped by 42,000 years of intentional fire management, by generations of knowledge about which places to burn and when and how. The open grasslands and heath that the colonists found and described as natural were partly the result of that management. When it ceased, the vegetation changed. The record of this relationship, the 42,000-year conversation between people and fire and vegetation and soil, is sealed in the peat below the buttongrass moorlands, in the lake sediment beneath the cold southern water, in the charcoal layers pressed between the pollen assemblages that chronicle the long response of the plant world to human presence. It is one of the longest records of human land management available anywhere on Earth, and most of it has not been read yet. Number 35, the island at the end of the world is still keeping its secrets. All archives have limits. The sealed record of Tasmania is extraordinary in its age, its completeness, and its preservation. But it is not infinite, and it will not last forever. Some of it has already been lost. More of it will be lost in the future, to the ordinary processes of disturbance and decay that affect everything eventually. The limestone caves are vulnerable to changes in hydrology. If the groundwater chemistry shifts, or if the drainage pattern of the cave system changes, the preservation conditions that have maintained the sediment deposits for tens of thousands of years can be disrupted. Cave flooding, in particular, can disturb sealed floor layers in ways that are not recoverable. The peat bogs are vulnerable to drainage. A change in the local water table, whether from climate-related shifts in rainfall or from deliberate drainage for agricultural or other purposes, can cause the peat to dry out and oxidize. Oxidized peat does not preserve pollen or charcoal or ancient DNA. It releases them as carbon dioxide. The cave art is vulnerable to moisture fluctuation. The ochre pigments that have survived for 20,000 years on cave walls in the protected stability of sealed caverns can be destroyed by repeated cycles of wetting and drying if the humidity regime in the cave changes. The World Heritage listing is a protection, but it is a human protection, and human protections have proved historically contingent. They exist as long as the political will to maintain them exists, and political will fluctuates. The sealed record of Tasmania is not guaranteed to survive. It has survived so far by a combination of natural preservation conditions and, in recent decades, legal protection. Those conditions could change, the protection could be weakened. The seals that have held for tens of thousands of years are not impervious to the specific pressures that the 21st century and those that follow it are likely to apply. This is not cause for despair. It is cause for the specific kind of urgency that attaches to irreplaceable things. The urgency of a library that is still intact but whose building has shown some cracks. The urgency of a record that is still legible but whose medium is not invulnerable. The island knows how to keep secrets. It has been keeping them for a very long time. It keeps them in the dark and the cold and the wet and the sealed chambers and the patient peat and the old wood in the lake beds and the bones of animals that no living person has ever seen. What it needs from us is simpler than the secrets themselves. It needs us to leave it alone long enough for the people with better tools to come and read it properly. That is all. Leave it alone. Let the seal hold. The archive will do the rest. It has been doing it for 42,000 years without any help from us. A little more time is not too much to ask. Number 36. The underground rivers. Nobody has followed to their source. Water finds the lowest point. In a karst landscape, the lowest point is often not visible from the surface. It is inside the rock, in a passage carved over millions of years, by the slow chemical action of slightly acidic groundwater working its way through limestone along fractures and bedding planes. In a sufficiently developed karst system, water that falls as rain on a catchment area many kilometers wide can converge into underground rivers that flow through passages of considerable size before emerging at a spring somewhere downstream. Tasmania has underground rivers. The most extensive karst systems in the Mole Creek area and in the cave-bearing limestones of the northwest and southwest are drained by underground watercourses that move significant volumes of water through passages that range from narrow tubes to sizable caverns. In the explored sections of these systems, the underground rivers have been followed, mapped, and studied. Their discharge rates have been measured. Their water chemistry has been analyzed. The cave biologists who work in them have found species of invertebrate living in the underground water that exist nowhere else on Earth, isolated for so long in the cave environment that they have evolved into forms completely dependent on it. But the explored sections of these underground rivers are not the whole systems. In many of the Tasmanian karst areas, the upstream portions of the underground drainage, the sections closest to the water input zones, have not been followed to their source. The passages are too tight, or they are flooded to the ceiling, or they are in parts of the landscape that have not yet been thoroughly surveyed. The water that emerges at the known cave passages began its underground journey somewhere, in a place that the cave explorers have not yet reached. What is in the unexplored upstream sections? At minimum, more cave, more passage, more of the specific underground environment that has sheltered cave-adapted organisms for potentially millions of years. More sediment on the cave floor, carried in by the water over thousands of years of flooding events. Each flood layer a time capsule of what the catchment contained at the time the flood occurred. More potential archaeological deposits if the upstream passages were accessible to people at some point in the past when conditions were different. In caves where the passage dimensions are sufficient, human access is a function of water level. A passage that is currently flooded to the ceiling is, in some cases, a passage that would have been walkable during drier climatic periods, when the groundwater table was lower and the cave drainage was more efficient. If people were in those areas during the last glacial maximum, when the climate was significantly drier and groundwater levels would have been different, they may have accessed passages that are now permanently flooded. The evidence for human use of caves that are now submerged exists elsewhere. In the flooded caves of the Yucatan Peninsula in Mexico, divers exploring the underwater passages of the cenote systems have found human remains, artifacts, and the bones of Pleistocene megafauna in sections that are now permanently underwater, but that were accessible during the glacial period. The principle is established. The application to Tasmanian cave systems is, as yet, largely theoretical. Largely. There have been dives in Tasmanian cave sumps by skilled cave divers, and the results have been, in some cases, surprising. Passages beyond the sumps that are larger than expected. Formations of exceptional quality in sections that have never been visited. In one case, a passage that connected two cave systems that were previously thought to be unrelated, suggesting that the mapped extent of those systems was a fraction of their actual extent. In the fully sealed sections, the sections that are beyond the current limits of cave diving in the Tasmanian context, there is water and rock and sediment and time. Lots of time. Number 37, the satellite that sees beneath the ground. One of the more unexpected tools now being applied to the question of what lies beneath the surface of places like Tasmania is satellite-based remote sensing, and some of the results challenge the assumption that what is underground must remain hidden until someone physically goes there to look. Ground-penetrating radar, operated from aircraft rather than from the ground, has a limited but real ability to detect subsurface features from altitude, particularly in areas of low electrical conductivity, where the radar signal penetrates further into the ground before being absorbed. In limestone terrain, which has relatively low conductivity, airborne radar systems can detect voids and density contrasts at depths of several meters. The application of airborne geophysics to Tasmanian limestone terrain has produced maps of subsurface density variation that correspond, in many cases, to known cave systems. Where the airborne data shows a density anomaly and a known cave has been surveyed in that area, the correspondence between the geophysical anomaly and the cave is generally good. This gives researchers confidence that anomalies in areas where no cave is currently known are likely to represent genuine subsurface features. There are density anomalies in the airborne geophysical data for parts of the Tasmanian karst that do not correspond to any known cave. In some cases, the anomalies are in accessible areas where ground survey has been conducted, and the absence of a known cave entrance in the vicinity is puzzling. In other cases, the anomalies are in parts of the southwest wilderness that have not been ground surveyed. The interpretation of geophysical anomalies is not straightforward. Not every anomaly is a cave. Variations in rock density, changes in lithology, mineral deposits, fracture zones without void spaces, all of these can produce anomalous geophysical signals. Distinguishing between them requires ground truthing, which requires getting to the location. But the pattern of anomalies in the unmapped areas of the Tasmanian southwest is, by the assessment of the researchers who have looked at it, consistent with the presence of a karst system of significant extent in areas that have never been investigated. Not a certainty, a consistency. The data looks the way the data would look if there were cave systems in those areas. This is not the dramatic discovery of a hidden city beneath the ground. It is the more modest but genuinely interesting finding that the tools available to science in the 21st century are able to detect from orbit or from altitude features beneath the surface of the Earth that human beings have never visited. Features whose existence can be inferred from the pattern of signals but whose contents remain, for now, entirely unknown. The satellite passes overhead, the signal goes down through the rock, the void reflects it back. And somewhere in a laboratory, a researcher looks at the data and says, there is something down there. What that something is, how old it is, what it contains, whether it has ever been entered, remains sealed. Beneath the forest, beneath the rain, at the end of the world, number 38, the first and the last and the distance between them. There is a specific kind of vertigo that comes from standing at the edge of very large numbers. 42,000 years is a number that the mind cannot hold directly. It is too large. The imagination reaches for it and finds that it keeps expanding away, receding as you approach. The way of a very distant mountain appears to get no closer as you walk toward it. What helps sometimes is to replace the abstraction with a specific image. Imagine a single human lifetime compressed into a single day. A person born at midnight and dying at midnight the following night. 24 hours? That is a long life, 70, 80, 90 years, laid out across a day. Now imagine 42,000 years as days. 42,000 days is approximately 115 years, a little more than a single long human lifetime. So the entire span of human occupation in Tasmania, from the first person to walk south across the land bridge to the disruption of European contact, fits inside roughly 1.5 human lifetimes measured in days. That is not very many days, but it represents, in real human experience, something impossible to compress further. 42,000 years of people waking up in the morning and going out to look for food, of children being born and old people dying, of seasons cycling and fires burning and rains falling and animals moving through the landscape, of language evolving and knowledge accumulating and stories carrying that knowledge from one generation to the next. Of specific places acquiring specific significance because of specific things that happened there, layered over so many generations that the reasons for the significance are eventually lost, but the significance itself persists. All of it is in the ground. All of it. The accumulated physical residue of 42,000 years of daily life in a specific landscape, sealed into the sediment, pressed into the cave floors, locked into the peat, held in the cold dark of the southern island. The first person to walk into what is now Tasmania was a specific individual, not a type, not a category, not a statistical unit. A person, with a face and a voice and specific knowledge and specific fears, and a specific way of carrying themselves through the world. They had a name, though we will never know what it was. They had a mother and a childhood and a way of reading the land. They walked south over the land that is now the Bass Strait, and they came to the place that would one day be an island, and they looked at it and they stayed. The last person to use the Kutikina Cave before the entrance was sealed by sediment was also a specific individual, someone who sat by a fire in that cave, in the light of the fire, and then left, and the cave held the ashes of their fire and the bones of their meal and the flakes of their tools, and the sediment accumulated over all of that, and the seal formed, and the years passed, and the fire got colder and colder, until even the idea of its warmth was compressed into a layer of charcoal a few millimeters thick. Somewhere in the dark beneath the floor, between those two people, the first arrival and the last cave fire, there is a distance measured in years that is larger than we can comfortably comprehend. But it is not empty distance. It is full. It is full of the specific lives of specific people, lived in a specific place, leaving specific traces. The traces are there. The distance is full, and the island is keeping it all quietly, in the dark, at the bottom of the world. Number 39, the color of the dark. Inside a sealed cave, there is a specific quality to darkness that exists in places that have not seen light for a very long time. Cave explorers describe it in different ways. Some say it is more complete than any other darkness. Some say it feels heavier than the dark of a room with the lights off, heavier than the dark of a night with no moon. Some say there is a quality of accumulated time to it, which is not a scientific description, but which the people who have been in sealed caves understand immediately. What they are describing, probably, is the absence of all the things that normal darkness still contains. In an ordinary dark room, there is the possibility of sound from elsewhere in the building, the distant movement of air, the faint reflection of distant light. In a cave that is far from any entrance, in a passage that has been sealed from the outside by collapsed rock or sediment and fill for thousands of years, there is none of that. The darkness is total, the silence is total. The temperature is constant, the same today as it was 1,000 years ago, as it was 10,000 years ago, as it was when the cave was first formed. When the first archaeologist pushes through the constriction into a sealed chamber and turns on a light, they are doing something that has not happened in that space for thousands of years, or ever. The light falls on the floor sediment and the cave walls, and any formations that have grown in the dark, and they see things that no one has seen before, or things that no one has seen since the last person was there. The floor of a sealed cave chamber, in that first moment of illumination, looks ordinary. Sediment, perhaps some flowstone, perhaps the pale shapes of stalactites descending from the ceiling. The sediment does not announce what it contains. It does not glow or give off a smell or present itself as the repository of ancient time that it is. It looks like dirt, but it is not dirt. It is an archive in the physical form of a soil column, and the things inside it are the most precisely dated and most completely preserved physical evidence of the past that exists in the natural world. In the sealed caves of southwestern Tasmania, in the chambers that have never been opened, the floor looks like this: undisturbed sediment, unilluminated, unexamined. The quality of the dark inside them is the quality of absolute geological patience, the patience of a place that has been keeping something safe for a very long time, with complete indifference to whether anyone ever comes to claim it. Whether anyone ever does is our decision, not the cave's. The cave has been making its decision for 42,000 years. Its answer has been consistent: hold, keep, wait, outro. That is where we will leave it tonight. We have covered a lot of ground, from the Ice Age refugium that preserved the oldest continuous human culture on Earth, to the karst caves whose sealed chambers have never been entered, to the drowned coastline at the bottom of the Bass Strait, to the peat bogs still accumulating their patient records in the cold southwest rain. We have spent time with the Huon pine and its memory of centuries, with the Paleogenomics revolution that is slowly learning to read ancient DNA, with the silence of sealed caves and the question of what we owe to things we have not yet found. What I hope you take from this, if you take anything, is not a checklist of impressive facts. It is more the feeling of scale. The sense that beneath the visible surface of a small island at the bottom of the world, there is a record of time that dwarfs everything we tend to think of as ancient, that the world has been here far longer than the world we have built, and that the record of its duration is not lost, not in Tasmania. It is sealed, and it is waiting, and it is, for now, intact. If this is the kind of material you find yourself returning to, the deep kind, the geological and archaeological and human kind, then this channel has a lot more of it. We spend time in places that do not usually get discussed: the unexplored basements of islands, the sealed archives of old landscapes, the questions that sit at the edge of what is currently known and look out at what is not known yet. If you have not already subscribed, consider doing it now. It is the simplest way to make sure you do not miss the next one. And if you want to tell me something about tonight, drop it in the comments. Tell me where you were listening from. Tell me what surprised you. Tell me if there is a corner of this material you want to go further into. I read those comments, and they shape what I work on, and I'm always genuinely interested in where people are in the world, when they find this kind of thing worth their time. Sleep well, wherever you are. The island is still there. The caves are still sealed. The peat is still accumulating, one layer at a time, in the cold southwest rain. And somewhere beneath it all, 42,000 years of silence is holding everything it was given to hold. Good night.